Okay, today we're going to continue with the Honors Pre-Calculus B semester exam review. And we left off with 57. We're going to start off with 58 now. 58 and 59 are both asking to go from polar form to rectangular form. So here is the, or excuse me, from rectangular to polar form. So here is the first problem. Okay, so this is obviously x and a y, so this is in rectangular form. And I'm going to be using the following formula. Okay, actually the following two formulas. Okay, remember that this gives a quadrant 1 angle. We can make a note that this is quadrant 4. So let's find R first. So here we're going to be going to polar form. Okay. So if I plug in 4 squared negative 4 root 3 squared equals R. And if I do this, I get down to square root of 16 plus 16 times 3, which is 48. Okay, and then if I add these, I get square root of 64. So R is plus or minus 8. Okay. Now you can also have, as you can see here, you can also have R be negative, but in this review packet they focus on R being positive. So I'm just going to write the positive case here. And so there's my R. And now I plug in to this formula to find theta. Okay. And if you look on the unit circle, tangent of pi over 3 is square root of 3. So tangent inverse of square root of 3 is pi over 3. Okay. But this is a quadrant 1 angle. I need to adjust this to be in quadrant 4, so I'm going to subtract 2 pi from pi over 3. And if you do that, you get 5 pi over 3. So there's theta. And equivalently, you could say 5 pi over 3 is also 300 degrees. Okay, so let's move on to 59, which is the exact same type of question. Okay, this is quadrant 3. So you can make a note of that. Same thing, use the R formula to find R. And we're just going to focus on R being positive. So R is square root of 2. This is polar. Okay, again we have R comma theta. And if I use the tangent inverse formula, I have 1. Okay, and this is pi over 4. If you look on the unit circle, and we are in quadrant 3 though, so I need to do pi plus pi over 4, which will give me 5 pi over 4, which is the actual theta. Okay, so there's number 59. Let's continue with number 60. Which of the following represents the same point as 4 comma negative pi over 3? So what you could do for this one is you can actually graph it. So it's going to be somewhere down here. Okay, and the way that I got that is I went out 4 and then an angle of negative pi over 3 as far as polar coordinates. Okay, so what you can see from this is if I have R being 4, what I could also do is I could go left 4, okay, and then make an angle here. Okay, so if I try and figure that out, my original is 4 comma negative pi over 3. And if I go to negative 4, what is the angle to get from here to here? And if you look at this, it's actually pi minus negative pi over 3. So start, if I go left 4, then I make an angle of 180 degrees, or pi, and then I go back this way, which is pi over 3. The angle is really pi minus pi over 3, which is 2 pi over 3. And that matches up with option B. Okay, so there's number 60. Let's continue with 61. So 61 and 62 are graphing polar equations. 61 is the following. So let's just make a note about this. So this is a cardioid, or excuse me, a limacon. A cardioid is a specific case of a limacon when A and B are both the same number, but this is a limacon. Okay, this is my best version of the French symbol there. So if I want to graph this, I can notice that A over B is 1 over 2, which is less than 1. So this has kind of an inner loop, okay, where this is A and this is B. So I'm just getting some information here. I'm going to graph this on a Cartesian graph first. Okay, so this has a period of 2 pi. So I'm going to split this up into fourths. It has a amplitude of 2 because of this 2, but it's shifted up 1, so it actually goes up to 3. Okay, and then if you plug in some points here, just evaluate all of these, you'll get the following. Okay, just plug in these to the equation. Okay, and then I like to make this table of r and theta, where I treat theta as my x and this as my y, as far as converting between this graph to a polar graph. And so now if I graph this in polar form, what I can do is I can first look at this graph here, and I see that if I plug an angle of 0, I get out 3. If I plug an angle of pi over 2, I get out 1. Angle of pi and negative 1, and so on, and just kind of goes back and forth. So 0 was 3, pi over 2, 1, pi, negative 1, 3 pi over 2, 1, and 2 pi 3. Okay, that should be enough. So the first point here, I'll go out 3 and make an angle of 0, so I stay there. Then I go out 1, make an angle of pi over 2. Then I go left 1. Now be careful with this one. Go left 1, make an angle of pi from here, puts me over here. So I have a point here. If I go right 3 and make an angle of, whoops, I skipped one. So if I go out 1, make an angle of 3 pi over 2, I end up down here. And then if I go out 3 and make an angle of 2 pi, I end up back here. So this is what this graph looks like. And you can see that it has that inner loop here that we said from the beginning. Okay, so just to recall that, so I went, the first point here, I went out 3, angle of 0, out 1, pi over 2, left 1, pi, out 1, 3 pi over 2, and then this one's repeated 3, 2 pi. Okay. All right, let's continue right along with number 62. So 62 has the following. This is my favorite polar graph. This is a rose curve. And it has 4 petals. So just to recall why that's true, if this is an even number, you double it, and that's the number of petals. If this is an odd number, like 3, 5, 7, those are the number of petals, okay? So if it's even, you double. If it's odd, you keep it, okay? So let's do the same thing. Let's graph this on an x, y axis first. So this has a period of pi, because there's a 2 here, so you do 2 pi divided by 2 is pi. Okay, that's what we talked about last semester. It also has an amplitude of 4 with no shifts up or down. So let's split this up. Okay, and in case you're wondering, just a quick way to do this, you just add these two and divide by 2 to get the middle one. So this is 3 pi over 4. Okay, and I'm just plugging these points to see where they end up. This one's pretty easy to do. Okay, make my r and theta table, where this is like x, this is like y. So when I plugged in 0, I got out 4. When I plugged in pi over 4, whoops. When I plugged in 0, I got out 0. When I plugged in pi over 4, I got 4. And then there's a lot of repetition here. Pi over 2, 0, 3 pi over 4, negative 4, pi, 0. Okay, and you'll see that these aren't actually enough points on this r theta table to graph this, but that's okay because there's a lot of symmetry here. So if you notice, one thing about rose curves with sine graphs, there are no petals on the x-axis, and kind of on the other side, if it's a cosine rose curve, there will be at least 1 petal on the x-axis. Okay, so this one will not have any petals on the y-axis, so we'll see some nice symmetry here. So 0, 0 is here. If I go out 4, just label these all 4s. Out 4, angle of pi over 4, that's roughly here. Okay. 0 pi over 2 is here again. Left 4 over angle of 3 pi over 4 will put me down here. Okay, and then 0 pi is here, and you can kind of guess by symmetry, because there has to be 4 petals, they will end up here. Okay, and you can label these better. I know I'm not labeling these very much, but you know, you can label this as an angle of pi over 4, and 3 pi over 4, 5 pi over 4, 7 pi over 4, etc. Okay, but this is your basic graph. Okay, so again, notice how I found the other petals just kind of by symmetry there. Okay, let's continue right along with number 63. Okay, so these 63 and 64 write each rectangular equation in polar form. So the key equations I'm going to use for this are the following. They're kind of your conversion equations. So if I start with x plus y equals 9, well, this one's not too bad. I can substitute x with r cosine theta, y with r sine theta, factor out an r. Usually you write these with r equals something as the format. Okay, and then you can simply just divide by cosine theta plus sine of theta on both sides, and that is your answer. Okay, let's continue with 64. This one is even easier. X equals 7. Well, x can be substituted using the previous page. Here, x is r cosine theta. So if I come here, I have r cosine theta equals 7. If you divide by cosine on both sides, you get 7 secant of theta, because 1 over cosine is secant. So this is your graph for that one, or your equation. Okay, let's continue with 65. So now we are going the other way. We're going from polar to Cartesian. Okay, this one's very easy. It's just y equals 6. Okay, again using the, well, I'll just refer back to the previous page. Y is equal to r sine of theta. Okay, so there is 65, and we'll just do 66 right here. Okay. 66 says r equals 3 over 2 cosine theta plus 5 sine theta. So what I'm going to do for this one is I'm going to multiply both sides by 2 cosine theta plus 5 sine theta. Okay, so those will cancel, and I'll get 2r cosine theta plus 5r sine theta. But this here is exactly x, and this here is exactly y. So that is my answer. Okay, so that is up to number 66, and we will continue in the next session. Thanks for watching.